Okay, so at this point you should have gone over circumcenters. That would have been the best place to start there. So we're at least a little bit used to incenters now. So very, very similar what we're going to be doing to these problems, but the only thing is that the rules change a little bit. So we still have a triangle here, but my incenter is my point. So we're talking about points. And points of triangles or points of concurrency. Concurrency just means of intersection. So we have a bunch of different lines intersecting here. Okay, we get the name incenter because it is the center of the inscribed circle. Okay, remember circumscribed goes around. Inscribed is going to be inside. So it's actually the center of that circle. That's where the name comes from, but you don't actually have to remember that. But we do want to know what types of lines are intersecting here. If I look at those three lines intersecting, we see that they have congruent marks on each side of the angle, which tells me that these are angle bisectors. So these are when angle bisectors intersect. Okay, so they intersect at the incenter. So these are a different set of rules here. I'm actually going to leave my inscribed circle in there. Okay, so instead of being equidistant from my vertices, like the circumcenter is, this is equidistant from the sides. So we see that those lines going out at 90 degrees are going to be that same distance. So I'm going to mark those as congruent. So those are equidistant from the sides. So just a lot of different rules to remember with all of our points of concurrency. Not super fun. Okay, so let's go ahead and list out kind of like the parts here. So we have angle bisectors. I'm going to keep that in blue. The angle bisectors are the lines cutting my angle in half. So we name that starting with the point in the middle. So P on B. We also have PC, and we have PA. So those are the three angle bisectors, and I find those again going out to those angles and cutting them in half. The incenter, of course, is just our point P. And then all congruent segments, so there is another set of rules here. So we know DP is congruent to EP is congruent to my third one, FP. So just listing out those that I marked as congruent, and I should have drawn those in orange. Sorry about that. Keeping with the colors. But we also have another rule that goes along with incenters. We know that either side of the angle bisector, or the angle that's being split in half, the sides of that angle are actually going to be congruent as well. So all you have to do is come over, find our three vertices, the 3 points that make the triangle. On either sides of those are going to be congruent. So I'm going to go ahead and mark those as congruent. I'm going to mark those as congruent. I'm going to mark those as congruent. So not a segment bisector here, but just equal sides of that angle. So another example, if we have a lot going on here. So AD is congruent to AF. I also know BD is congruent to BE. And I also know CE is congruent to CF. So again, a lot going on here and a lot to remember. So I'll go through the first example with you and then let you finish the rest. Okay, P is the incenter, which tells me a lot of information. The only thing I'm really going to mark right now, other than my incenter, is that all of these little segments to the sides are going to be congruent. So here they're all going to be 8. Okay, so I think the best option for this is just to go through one at a time, each of these. So in P, let's go ahead and highlight in P. Oh, that's the one that we just found, so that one should be easy. We already knew that that one is 8. Let's look at NK. NK is this side over here. We see that the other side of that angle is 17, which means that side is going to be 17. So either side of that angle are going to be exactly the same. And here comes the hard part. We got to do some Pythagorean theorem. Let's find PK. So PK is that angle bisector. So I look, they've already kind of created this, or I've kind of already highlighted that right triangle. You don't have to necessarily draw it out unless that helps you, like I did through the other example. Let's just do this one, just working straight on the picture. So I'm using this triangle that I highlighted, and I'm looking for that side PK, so I'm just going to mark it with an X. I know that this side, I'm going to rewrite that over there, is 8, and then my other side is 17. So going through Pythagorean, I'm going to go ahead and list this out. This is for PK. First thing I want to do is find my hypotenuse. So draw your arrow across from the box, and my hypotenuse is X. Could have left it as C, that's fine. And then it doesn't matter which one we choose for A and which one we choose for B. And from this point, we're just working through this. So 8 squared is 64. I'll give you a second to plug in your calculator, 17 squared. Remember, in the calculator, you want to do 17 and then the button that looks like that, if you're not sure. And that should automatically square 17 for us and get 289. And then we have x squared. Let's go ahead and combine those like terms. And we should get 353 there. And last step, to get rid of the square, I square root each side. Remember, you're hitting the button that looks like this. So 353, and then our button. And we should get x equals, let's round to the nearest tenth, 18.8. So that is our side in the middle, or our angle bisector. In our last one, we were solving for LO. I'm going to kind of clear some of this out. Gets a little messy there. So I know that side is 8. I'm looking for LO, so I'm going to put an X there. And then I have this angle bisector there. Remember, the angle bisectors are not all congruent. So it looks like we're going to have to do Pythagorean for this one as well. I'm going to change colors here. So first thing I want to do is find my hypotenuse. In this case, it's a number, 13. And then I'm just going to put them in whatever order. And let's go ahead and solve. So 8 squared is 64. That's 169. Let's go ahead and subtract 169 minus 64. We get x squared equals 105, and let's square root that number. I'll give you a second to do that in your calculator. And that should give us 10.2. So these are not the most fun, kind of like a puzzle you're having to solve, which if you like puzzles, this might be fun. But a lot of work goes into these types of questions when they're dealing with Pythagorean. So you have quite a bit of notes to finish. You have a section for Circumcenter and a section for Incenter. What I would like for you to do is try them all on your own, and then go check with the answer key. The sub has the answer key there. So good luck, and I will see you guys on Thursday. The homework will be due on Thursday as well.